In this video, I'm going to show you how to do an applications question of circular functions. So looking at sine and cosine kind of wave graphs, and just going through what the important things are when you're looking at an applications question and the little tricks and tips on how to make sure that you get all your answers right. Okay, so this question is talking about tide. Now you get a lot of tide questions because tides are sinusoidal in nature, so often you'll find questions about water levels and that kind of thing. So this is a sort of a fairly typical question. Whenever you're doing these, always bear in mind the context of the question. It'll just help you make sure that you check your answers, that the answers you're getting make sense, that you sort of respond in the correct kind of way. So we'll go through this and I'll point those out as we go. So it's suggested that the height of the tide above mean sea level on the 1st of January at Warnung is given by this rule. Okay, 4 sine pi on 6t, where t is the number of hours after midnight. Now that's important. Okay, we'll come back to that. The first thing it says is draw a graph of this for t between 0 and 24. So we're looking at a 24-hour period. Okay, you could do this on your class pad, but it's good practice to be able to do it without. So let's have a look at what we're doing here. So the first thing we notice is that we've got vertical dilation. Okay, so we know the amplitude is going to be 4. So that's pretty easy to do. Just need to dilate it, stretch it vertically by 4. We also have a horizontal dilation here. Okay, and remember that the dilation is the inverse of that. So the horizontal dilation is a factor of 6 over pi. Okay, which means that we are going to multiply every point on the horizontal axis by 6 over pi. So where the normal period of sine, so generally the period of sine is, sine x is 2 pi, okay, when we apply this, what you want to do is multiply those to get two together. So you get 6 over pi times 2 pi, pi's cancel out, and you get 12. Okay, so this is the period of the new function here. Alright, so the fact that there's a pi in there, don't let that scare you. It's just the same as we did before. It's always, you've got to find the inverse. Remember, inverse? Oops. Okay, and in this case it's quite good because it means the pi's cancel out, so you get a nice whole number. So we've got an amplitude of 4, we know the period is 12, and we are plotting over 0 to 24. Okay, it's a sine function, so it's going to start at 0 point here. Okay, and it's going to go up, down. Now that's one cycle. Sorry, that should be a bit more even. So we know that's 12, but it wants us to go to 24, so we're going to do another one. Okay, and that's typical of a tide. Now we've got 12, we know that's 24, which means these points must be between 6, 18. Okay, so they're all the points where your tide is at mean sea level. This is above mean, this is below mean. Obviously this is high tide up here, that's going to occur at 3 and at 15. Okay, we've got low tide here, 9 and 21. Alright, this is 4 meters, and this is -4. Okay, so they're all your sort of salient points on here. This is t, and this is the height in terms of t. Okay, so that's what your water level is doing. So that's your graph for that one. So the question says, when was the high tide? Okay, so we've already found out that high tide is when t equals 3 and 15. Now that's not good enough. Okay, t equals 3 and 15 isn't good enough. It said when was the high tide, so you need to give a time. So t equals 3 means 3 hours after midnight, so therefore at 3 a.m. and 15 hours after midnight, which is obviously going to be 3 p.m. or 1500 hours if you're going to do 24-hour time. Okay, but you need to state those two. That's your answer there. What do we got? What is the height of the high tide? Well, that's pretty straightforward. The height is just going to be 4 meters, and that's above mean sea level. Above mean sea level. Okay, don't just say 4 meters. 4 meters what? Alright, make sure that you're referencing back to the question. So 4 meters above mean sea level. So that's your first 3 parts. Fairly straightforward so far. Okay, now we've got what is the height of the tide at 8 a.m. So there's a couple of ways you could do this. You could solve it. I'm just going to flick over to a new page. you could solve it. So height of the tide at 8 a.m. means you're just putting in basically what you're trying to find is h when t equals 8. Okay, so that gives you 4 sine pi on 6 times 8. Okay, you can work that out, or you can just plug that in your ClassPad. Alright, and if you do plug it in your ClassPad, what you get is minus 3.46 meters. Okay, so the height of the tide at 8 a.m. is 3.46 meters below mean sea level. If you did this by hand, using your exact values, what you would have found was that this is 2 root 3. Okay, but 2 root 3, I mean, if you're a harbour master and somebody says, what's the height of the tide going to be at 8 a.m. and you say it's going to be 2 root 3 meters, they're probably going to look at you funny. Okay, so in the context of this question, this makes more sense. All right, so it's 3.46 meters below mean sea level. And part E. So part E says the boat can only cross the harbour bar when the tide is at least 1 meter above mean sea level. Okay, so when can it cross the harbour bar? So we go back to here. What we're going to do is find where is it 1, so that's like sort of about here. Okay, and where is it above 1? So clearly there's a window of opportunity there and a window of opportunity there. Alright, so what we need to do is find out what's that, what are those values there? So what are the t values when the height is 1? Okay, and again, you can solve this by hand, easier on the ClassPad. Alright, so let's pop it in here. You should get y equals 4. We'll be using our shortcuts, shift 1, sine shift pi on 6 times x. I'll put the x in there. Okay, so that's our function. Open your graph window, pop this in here. Alright, that looks pretty good. Adjust as necessary if you need to. So we should have, is that what we've got there? Yep, down to here. So that's 24. That looks good. Adjust your view window so you can see what's going on. Now what we want to find is what is the value when, the t value when y equals 1. So gsolve, xy calc. We want an x calc because we know what the y value is. Y value is 1. Okay. And what we got here is 0.4825 or 26. To that one, 5.5174. Okay, so between those two values. Then from here, 12.4826 and 17.5174. So as you would expect, the difference there is just 12 hours. So once you found out these ones, then you can just add 12 to get the other two, which makes sense because the period is 12. Okay, but again, if you say, you know, it's going to be 17.5174, that doesn't make a lot of sense. So how are you going to answer this question? All right, so the sort of format that you want to answer it in is work out, well, what we found was that the values are t is 0.4826. So between 0.4826 and 5.5174, and also from 12.4826 to 17.5174. But you want to find out what's this in terms of minutes. Okay, these are decimals. So what time is that? Okay, so the times turn out to be, well, this 0.4826 is about 29 minutes. So we're looking at 12:29 a.m., 29 minutes after midnight, to 5, and this turns out to be about 31 minutes, 5:31 a.m. Okay, and then again in the PM. So 12:29 p.m. and 5:31 p.m. Or you could write it in 24-hour time, as long as you're clear that you've got two windows and that you can give sensible times. Okay, so as always, when you've got applications questions, think about the context of the question. Okay, what is the question actually asking you? What is the information that you're trying to provide? We're not just doing maths for the sake of maths, you're actually trying to provide something useful. So picture the real world situation. If somebody asked you, you know, what is high tide, you wouldn't give them a square root answer. So always keep that in mind when you've got applications questions. Check the reasonableness of your answers. Okay, if you're getting, the typical one is if you're getting negative answers, then you shouldn't be getting negative answers. just make sure that you're thinking about that. And also answer in the context of the question. Okay, do you need to discount or restrict solutions? Is there something where when you get a solution, one of them doesn't make sense? Okay, what units are you using? So that prime example here, this is correct, but it's not useful. So because it's not time, it's time in decimal. We don't do time in decimal, so you need to write it in hours and minutes. So that's what you're thinking about. Also a summary sentence. Okay, if you've got a question generally that's a worded question, you should answer as a sentence. That's your sort of rule of thumb. So if you bear all that in mind, maths is usually not that complicated, but you've just got to make sure that you are actually answering the question.